All right, section 7.5, we're going to be solving systems by elimination. And I forgot to pick up my tablet, so give me 1 second. There we go. So in section 7.3, we talked about solving systems by graphing. 7.4, we solve systems by substitution, and then 7.5, solve by elimination. In some sense, it doesn't really matter whether we do substitution or elimination. Either one is perfectly fine. But sometimes the system is set up to use substitution, sometimes it's set up to use elimination. So for example, if I had 2x plus 3y is equal to 10 and y is equal to 4x minus 8, notice I have one of my equations solved for one of my variables. So this is really set up for substitution. You don't have to use it. You can use the elimination method, but it's really kind of intended that you use substitution. On the other hand, if you have 2x plus 3y and negative 2x plus 7y, so in this case, this one's actually set up for elimination. How can we tell that it's set up for elimination? Well, notice both of my equations are in standard form. So when both equations are already in standard form, then elimination method is usually the preferred method. Doesn't mean you can't use substitution, it just means that it would be a little bit easier to use the elimination method. All right, so here we go. The elimination method actually has many different names. And it really just depends on the textbook you happen to be using. In I teach college classes, and one of the textbooks that I use for my college class, they call it the addition method. This is actually the name of the method that I learned when I was in high school. They called it the addition method. By the time I started teaching college, they had switched the name. They started calling it the elimination method. And then when I started teaching high school, they started calling it linear combinations. To be perfectly honest, I will probably use these two names interchangeably. It really just kind of depends on what comes out of my mouth at the time. So when I say the addition method, know that I'm talking about elimination. If I say elimination, know that I'm talking about addition. They're the same method. Okay, so there's actually reasons why they used to call it the addition method, and that's because you add the equations together. So we add the x's together, yeah, they add the x to the x, so I have 5x, and I add the y's together, but notice if I have a negative y plus y, my y's are eliminated, that's why they call it the elimination method, and I have 10, so I divide by 5, and I get x is equal to 2. Then I need to substitute it into one of the originals, doesn't matter which. I am probably going to use the bottom equation, smaller numbers, and they're all positive. So replace my x. So I'm using this equation right here to find my y value. And I subtract 4, and I get y is equal to negative 1. All right, so steps involved. First thing, both equations have to be in standard form. Standard form, remember, the x and the y have to be on the left-hand side and the constant on the right. Occasionally, you may have to transform one of the equations, sometimes both, so that the coefficients, so this is important, the coefficients of one pair of variable terms are opposites. So for example, I can either have, So let's suppose I have a positive 2x, and this is x, and plus y and stuff. In order for my x's to cancel, this would need to be a negative 2x. In order to make it negative 2, I might have to multiply. All right. Then you would add the equations together, solve, find the other value, and check. All right, so this, actually neither equation is in standard form. So we're going to add y to the first equation. So x plus y, and I'm also going to add 2. So here's my x plus y equals 2. That's my top equation. For the bottom equation, I'm going to subtract y. So I have 2x minus y is equal to 10. Now, when I do this, remember, my goal is to add the equations together, but I have to have one of my variables eliminate. So notice this is 2. For my x's to eliminate, this would have to be negative 2. And it's not right now. This is positive 1y, this is negative 1y. These are opposites, which means if I add them together, they would cancel out or eliminate. So my y's are going to eliminate. I'm going to add my x's, and I'm going to divide by 3, and I get x is equal to 4. And I need to find my y, so I am probably going to put it into the top equation. Numbers are smaller. So I substituted my x for, as 4. So I get 2 is equal to negative y divided by negative 1. Right, like that. All right, so sometimes we need to multiply one or both equations by a number before we can add so that one of the variables is eliminated. Like this problem, for example. Notice this is a positive 5, this is a positive 10. When I add them together, we get 15. They do not eliminate. This is a 1, this is a negative 7. When we add them together, they do not eliminate. Okay, so I'm going to have to multiply one equation, sometimes 2, by a number so that one of the variables will eliminate. Basically, it's just kind of a whichever variable looks easier to you. Typically, if we have a coefficient of 1, for one of the variables, that would be the variable that we eliminate, just because it's usually a little bit easier. So if I want my y's to eliminate, then this would need to be a positive 7. But for this to be a positive 7, I would have to multiply the y by positive 7, but I can't just do it to one term. I have to multiply every term by the same thing. So 35x plus 7y is equal to 63. And I'm going to add them together. And offhand, is it 45? 63 minus 18. It is. We get x is equal to 1. So I'm going to substitute in, I'm probably going to do the top one. 5 times 1. Subtract my 5. And I get 4. Now, some of you may have said, but wait a minute, can I cancel the x's? I could just multiply this top equation by negative 2. Perfectly fine. So you multiply the top equation by negative 2. And no, you don't have to do it both ways. I'm just showing you what it would look like if you were to do that. So you would have negative 9y is equal to negative 36. And you get y is equal to 4. So you're just solving for a different variable, first off. And then you would have to solve for your x. So yeah, doesn't matter. Whichever works better for you. This one, on the other hand, we've got a 4, we've got a 3, we've got a negative 5, and we've got a positive 2. So there's no easy way to eliminate one of my variables, okay? So rather than multiplying one equation, there's no way I can multiply by a single number to turn a 4 into a 3, or to turn a 5 into a 2, or vice versa. So what I'm going to have to do is pick a variable. I'm probably going to pick y because I already have one negative and one positive. And then I'm going to find the smallest number that they both go into, the least common multiple. The smallest number that they both go into is 10. So I'm going to turn the 5 into a 10 and the 2 into a 10. So in other words, I got to multiply both equations. To turn the 5 into a 10, I'm going to multiply by a positive 2 because I actually want it to be negative 10. To turn the 2 into a positive 10, I'm going to multiply by 5. So 8x minus 10y, negative 36, 15x plus 10y is negative 10. And I get, what do I get? 23x, my y's eliminate, negative 46, divide by 23. And I get x is equal to negative 2, which I'm probably going to substitute into the bottom equation. So 3 plus 2y, negative 6, add 6, and divide by 2. So final answer, negative 2, 2. All right. Did we eliminate the y? We did eliminate the y. Previous example, we eliminated the variable y. We could have just as easily multiplied each equation so that we eliminate the x. It doesn't matter. But something you have to remember, this is important. Multiply both sides. You have to multiply the constant. Everybody always forgets to multiply the constant. Multiply both sides means you also have to multiply the constant. And this is where I wanted to cut off this first video. So we're going to stop here and then pick it up in another video.